So we're talking about unit testing. Yeah, I just need to check now that I'm not muted. I'm not. We're talking about unit testing in particular. There are a number of aspects to automated testing, unit testing, integration testing, end-to-end testing. We'll talk about each of them, but for now, it's just unit testing, where a unit is just typically a class, and the class has methods, and so we would write tests for each method. Now, we could write our testing code using just plain JavaScript, but that wouldn't really scale very well. So instead, we use a testing framework. And there are many of them. The most popular one in the JavaScript world is definitely the Mocha framework. So what Mocha will do for us is it will guide us as to how we structure our testing code, and it will also take care of running the tests and producing reports or output for us. So I'm saying there at the very beginning, it's an execution environment for automated JavaScript unit tests. It actually goes broader than unit tests, but for now it's okay. In terms of us writing our testing code, what Mocha requires us to do is to use certain structures, describe blocks, it blocks, and before and after hooks. We'll see those in a second. And the way it kind of works, I suppose I could fast forward on to the next slide. This is how all of your Mocha tests are going to look. So at the very outer level, you're going to have a describe block where you specify essentially kind of the name of the class that you're testing. Although this is just a string, so it isn't as if Mocha checks to see does the class name here correspond to a valid class in your code. It's just a string really, but the logical thing would be to give it a name. And the second argument, because really this is just a JavaScript function in a sense, okay, and this is the first argument. And the second argument is an anonymous function. So it is JavaScript at the end of the day, but think of it in terms of describe blocks, it blocks, nested describe blocks, etc., etc. So anyway, this is a function. It begins here and it ends all the way down here. So from a syntax point of view, it takes a little bit of getting used to. So inside in this function, we typically have a before block followed by perhaps another nested describe block. Typically, this describe block is concerned with encapsulating the tests for a particular method of the class. Again, it's a describe block, so it takes the same number of arguments. It takes a string, where usually in this case, the string would contain the method name. And then the other second argument is a anonymous function again. This one begins here, ends here. Inside in this inner describe block, then you typically have a number of it blocks. And so each it block would be concerned with testing one aspect of this method. And so depending on how much functionality is in the method, you may have a number of it blocks. The important thing is though that each it block is just concerned with testing one aspect of the method. We'll come on to talk about how you might break up the aspects of a method later on. In terms of our given when then kind of structure for designing test cases, loosely the given stuff appears inside here in the before. The idea now is that at runtime, what Mocha will do is for each, we call this a test case. For each test case, it will first run the code inside in the before block, and then it will run the code inside the it block. Then it runs the code inside the before block again, and then it runs the next it block. it runs the before block yet again and runs the next it block, and it keeps on in that sequence. So it executes the before block before each it block, and it works its way down through the rest of, because you may have other inner describe blocks down here, because more than likely you're going to have multiple methods. And inside an init block, it's in here that you actually call the method that is being tested. So it's kind of the when, and you then follow that typically with statements where you're stating expectations about what the method should have returned back to you. That's typically what appears inside here. Here's a kind of an actual, and this is what you will be doing in the labs. In the lab, we have these two classes. You can ignore these ones here. We've got a product class, which is simple. It's trivial. We don't need to do any testing on that. And then we've got this product catalog class, which as part of its internal state, it has an array of products, and it has various methods then associated with a catalog. So a method to find a product, a method to add a product, remove a product, etc., etc. So that's the class that I want to test. I would call that my target of my tests. And I've written tests then inside this file here. And here we go. Here's our describe block. And I've got a before block, and I've got an inner describe, and I've got various it blocks, and on it goes. So you're going to be developing this, rolling this out. I give you the code really in most cases. So it's kind of a cut and paste. Just let's study it for a second. In the before block, you can see what I'm doing is I'm creating a new catalog instance, and I'm adding some products to it. And then, so here I'm testing my find product by ID. That's the objective. And the find product by ID method, it's fairly obvious what it does from its name anyway. But maybe let's just, it's obvious to me maybe, but not to you. Let's just look at this method that we're testing. Find product by ID, the idea is you pass it a product ID, and it essentially checks this array to see, is the product in there? And if it is, it returns it. If it's not, it returns undefined. That's how I've decided this method should work. This is the specifics of the implementation. So it's a very trivial method, but still, let's start with something small. So this method returns undefined, or it returns a product that it has found, a product object that it has found inside this array, where a product object looks like that. Yeah. Back to my test. And here I have my two tests for that method. There are obviously only two different kind of cases, when it finds a match and when it doesn't find a match. Here I go, I actually call my find product by ID with this particular ID, and I know this product should be in my catalog because I've put it in up here. And the method result now in this case should be a product. And let's not worry about this line here, but essentially what I'm doing here is I'm checking to see, is the product that was returned back, does it have the name product 1? Because you can see up here, product 1 was the name associated with that ID. Down here, then I'm testing the second test case, where, and you can tell kind of from the sentence here, right, what this case is about. I'm saying it should return undefined for an invalid product ID. That's an invalid product ID based on what I've put in up here. And so in this case, I'm checking to see this statement here. Again, I'll talk a bit more about these expectation statements. This is an expectation statement, but you can tell from what it's trying to state. It's trying to state that the result should be equal to the value undefined. And then I have another test for another method, and on it goes. Right. So that's how we structure our tests. So if I go back one level again, so I've got each test case is wrapped in an it block. So each method would have a number of test cases depending on how much functionality is in the method. Related test cases are grouped inside a describe block. Obviously, all of the test cases for a particular method, we should put those into one unit, and we call that unit a describe block. And describe blocks can be nested, I'm saying here, and we've seen that. And in fact, if you've got a very involved method, you may actually decide to break its tests up into a number of describe blocks rather than just one. You know, for my find product, by ID, it's a fairly simple method. So I didn't really need to create further nesting of describe blocks here. I'm not sure if I do it later on. Maybe I don't, but you can anyway. So you've got a lot of flexibility in terms of how you structure this stuff. Just some terminology. We talk about the target of our tests. So in that little use case or that little case study, the target would have been my catalog class, and the individual methods would be targets. We talk about a unit test. So a unit test is a test for a particular unit of your source code. And the units in this case are individual JavaScript classes. And I'm saying that a test case is the group of tests for a single unit. Oh yeah, that's okay. I'm saying a unit test is comprised of test cases. So there are test cases for the various methods. Now you're going to have lots of classes in your application. So a collection of unit tests is called a test suite. These are just terms that we use. So targets, unit test, test case, test suite. Some principles, high-level kind of principles of testing. Number one, test case isolation. Essentially, you want each test case, and again, by test case, if I go back, I'm saying that each of these is a test case. Each it block is a test case. Each test case should run independently of every other test case. And that is the test isolation principle. And the way we actually achieve that is by the way Mocha allows us to achieve that is by having the before each block. It executes that before each block, before each it block. So it essentially kind of regenerates any initial data for us before each it block. In the case of our catalog, we created a new catalog object and added the products to that catalog. We do that every single time before each it block executes. It wouldn't make a whole lot of difference in the case of the find product by ID, but when we come to testing the remove products by ID, then obviously our it blocks are going to be removing products from the catalog. And so we want to make sure that when we run the next it block, that the catalog is reset back to its initial state. Its initial state, I've decided, is that it should have 3 products inside in it. Okay, so this test case isolation is really important. Otherwise, you can have a knock-on effect from one test case to the next, and you don't want that. So that's this idea of test case isolation, and Mocha guarantees that for you. Number 2, I'm saying you should test the target state as well as the response. So we call a method and we obviously check to see, did the method return the right result? Or we state an expectation about the result that was returned by the method. But if the method is meant to carry out some state change within the target object, my target object in my case study is the catalog. If the method that I'm testing is meant to change some part of the catalog, for example, if it's meant to put something into the array of products or remove something from the array of products or change one of the products in the array, that's what I mean by a state change, then our test case should also check to ensure that it did actually make that state change. So there's 2 things that you need to check when you are writing your test cases. A, did the target method return the right response? And B, did it make the relevant state change? If it is meant to make a state change, some methods don't, and that's okay. So the find product by ID method, it doesn't make any state change. It just returns something. However, I also had a method called remove product by ID. And from its name, you can determine that it's meant to make some change to the array of products. In the case, if I look at it, I've decided that the remove product by ID method, we just check the code really. I just kind of arbitrarily decided that it should return the product that it has removed if it actually found it. And if it doesn't find it, it should return undefined, I think. Is that what I'm doing? Yeah, it should return undefined. So I arbitrarily decided that they should return undefined if it didn't find the product. And if it did find the product, it should remove it and return the actual product that it has removed. So it's definitely making a state change as well as returning something. The state change is clearly going on inside here. Now, in terms of testing this particular method, I should make sure that not only does it return the right result, but it also makes the necessary internal change to the catalog, which I call a state change. That's principle number 2. What most people get right is they test that the target method return the right answer, but what they forget is to check to make the state change check. Principle number 3 is a lesser principle in a way, really, but still kind of important. Really, when you run your test cases, all you really want to be told is, did they work or didn't they? It's kind of a yes or no. You shouldn't have lots of console.logs being generated by your test cases. So what we say is that the test execution should be silent. It should either tell us yes or no, the test passed or they didn't. If a test failed, for sure, we would like to know which test failed. But other than that, we don't want to be given loads of output that we're not really interested in. So it's this idea of the silent principle. Keep your console.logs, don't have them scattered inside your testing code. You may need to put them in there initially when you're doing some debugging, but when you're finished your debugging, your tests should be silent. Because we know that regression testing is very important. We keep rerunning our tests, and you don't want streams of unnecessary output coming from those tests. Test number 4, I'm saying, is have informative test case documentation. What do I mean by that? That actually refers to, if you looked at the it blocks, if you the text that you put here, the first argument of the it block, it's English obviously, and it should be a clear statement of what this test case is really about in terms of what the test should do. Right, that's what I mean by clear documentation of your test cases. This is really the documentation. The describe blocks are straightforward enough. Typically it's method name, class name, but make sure that you express these things succinctly and accurately as well. So there are some principles. Next, you could be writing loads and loads of automated tests, but you got to stop at some stage, and you've got to make sure that you're doing enough testing, that you're testing all possible scenarios, but you're not doing unnecessary testing. If a particular scenario works for one test, then there isn't really much point in writing another test to prove that it works for another similar scenario. So what I'm documenting here on this slide is some guidelines as to how you know whether you have written enough tests or not. And so if you think of, let's bring it down to an individual testing of a particular method of a class. If you think of the three possible types of scenarios that this method could be invoked, some of the scenarios may not apply to some tests, but this is for the more general case. So scenario number one is what I'm calling the normal scenario. That is where you're calling your target method. The parameters that you're passing have normal values, and the result that it turns back is normal. Okay, so in the case of our find remove product by ID or find product by ID, there are two normal cases for both of those, as it turns out. We would all get those right. Number two, then I'm saying you should think about error scenarios. So an error scenario is, I guess, essentially, if you've got a method that has code in it that causes the method to throw an exception, then you must test that it does throw that exception when it should throw it, and that it does not throw the exception when it shouldn't. Okay, so you need to design test cases to test the error handling side of your target method as well. And what causes a method to throw an exception really depends on the nature of what the method is doing. So it could be that it receives invalid arguments, or it could be that the state of the target object is invalid. So you've got to create the situation which would cause the method to throw its exception. And the third scenario then is one that people miss out on or have a difficulty understanding, what I'm calling the boundary cases. Now, some methods may not have any boundary cases associated with them. You've got to think about them, but in general, the boundary scenarios, they're also referred to as edge or corner cases. If you think of a method, let's say that one of its arguments is an integer, and there are upper and lower limits on what the value of the integer should be. So the boundary cases for that method would be when you invoke it and the integer parameter is just on its upper limit and also just on its lower limit. There would be two separate test cases. You should think about testing your target method with those boundary values, which would be different from the normal cases. Okay, the normal case might be where the integer has some value in between its upper and lower bounds. Also, boundary cases may relate to the internal state of the target object. in the case of our catalog, what if our catalog was empty, if the array of products was empty? Does our target method behave in that kind of boundary case or edge case? I don't have an upper limit in terms of the number of products in the catalog, but maybe for a particular application, there may be some upper limit on the size of the catalog. Well, then you would have a test case where the catalog is at that upper limit, and you would test that the various methods behave properly when the catalog is at its upper limit. So you just need to think about these. They're not easy to identify. You need to dwell on them a little bit to identify them, I think. 1 and 2 are easy to work out, normal cases and the error cases. The error cases, as I said, simply would be if your target method actually has some exception handling code in it. Number 3 is one that you need to reflect on, but they're equally important. Now, so Mocha guides us in terms of how we structure our code. And there's a second library called the Chai library, which we use with Mocha. And what Chai library is all about is expressing the expectations in our testing code. The expectations, if you remember, are the in terms of our given, when, then. It's the kind of the then part of our user stories. What do we expect to happen when we invoke a particular method? As in, what do we expect the method to return, and what state change do we expect it to carry out on the target object? How we express these expectations, we could express them just using standard if statements, but there are libraries, for example, the Chai library, which provide a syntax that allow us to express these expectations in almost an English-like fashion. And you saw them there in the samples that I was showing you. So these statements here, or these expressions, are expectation statements. They are just JavaScript. And in my case, I am using the Chai library. I've imported the Chai library here, and I'm accessing a particular object that's available to me within the Chai library. So this object has loads of methods associated with it that we can use in order to express expectations in our code. And as I said, they kind of read almost English-like. So the design of this Chai library is what we refer to as being of a fluent style. But really, it is still just JavaScript. And you kind of have to pick up this syntax over time, really. And hopefully, I'm giving you lots of examples in the lab that will allow you to just get some knowledge on what kind of expressions you can construct using this expectation syntax that's provided by Chai. But it is plain old JavaScript at the end of the day. So we use it with Mocha. Mocha does have its own expectation syntax, but certainly Chai is considered much better, actually. And the design of the Chai library, I'm saying there in the second bullet point, it has a kind of a fluent coding style. It's really kind of meta chaining, but this fluent coding style allows us to express expectations in an English-like almost way, or in an expressive way, I suppose I should say. Now, what I'm showing you here really is kind of a full list of all the different, well, maybe not all of them, but most of them, all of the different types of expectation expressions that are available to you from Chai. And I've used quite a number of them in the product catalog little case study so that you have some working examples of them. All I'm saying here is that the Chai library, it actually provides 3 different ways of writing expectation statements, either using the assert approach, the expect approach, or the should approach. I'm using the expect approach in the lab exercise, because I think it's probably the most expressive form of these expectation statements. So it will take you a little bit of while to get used to that syntax, that Chai expectation statement syntax. But you know, you pick it up, I think, after a little while once you see lots of examples. Here's some more examples that you can look at later on. But hopefully the lab will help you as well. So the next thing I want to briefly talk about is something called test-driven development, or TDD. And the idea is when you are tasked with implementing a particular, let's say, a method of a class, and you have been given a specification for what that method should do, the suggestion is that you should actually follow this kind of approach. And it's quite difficult, actually. It's a difficult discipline, but let's just step our way through it. So the starting point now is you have a specification for the implementation of a particular method for a particular class. That's your starting point. So the suggestion is take one part of that specification and write a test case for that particular part of the specification. Okay, and you actually write the test first. You check to make sure that your test code is syntactically clean, obviously, and fix any errors in the test code. You haven't written any part of the target method at all now yet, oddly enough. The next thing you do is you write a stub implementation of the method that you want to test. Now, by a stub implementation, it would simply have one line of code. Let's say it returns null. That's it. So really the method doesn't do anything, even though you've written a test now for the method for a particular part of the method specification. You run the test, and clearly the test is going to fail because the method isn't doing anything. The next thing you do is you just write enough of code in the method so that the test that you have written will pass. So you do that. Now you run the test again, and presumably the test will pass if you've done the little bit of implementation correctly. If not, you go back here and you change the implementation so that the one test that you have written will pass. So once you've gotten to this stage successfully, you now have implemented one part of the specification for the method, and you have a test for that part. So that's all working. You might actually, now that it is working, you might actually look at your implementation of your target method and maybe refactor it a little bit. If you do refactor it, refactoring, remember, is changing the design of your code without actually adding any new features to the code. You're just redesigning it. But if you do some refactoring, then clearly you should run the test again to make sure that you haven't actually broken the test as a result of the refactoring. Which brings us back to here. Now you take another part of the specification for the method that you've been given, and you write a second test for that new part of the specification. Check to make sure it's syntactically okay. Run the test. It's going to, the first test is going to pass, but the second test is going to fail because you haven't actually expanded your target method. Now you implement or extend the target method so that the second test that you have written will pass. And you stay here inside in this part of the process until the new test pass, and critically the first test passes as well, because you don't want to break that. Once you get to the stage where your two tests are now passing, you may do some refactoring. You come back here again, you take another part of the specification, and you continue on in that way. And so what's characteristic here is this idea that your tests are actually driving the development. You're writing the test first before you implement the particular part of the target. Quite a difficult skill, but there are many benefits to it. And I step you through an illustration of that in the lab, and then I kind of challenge you to see whether you can try and follow the process yourselves for another method for which I give you the specification as to what the method should do. And you see how you get on. It is quite difficult, I will admit. These are the key points of this test-driven development, or TDD process. The idea that you write tests before the code. It's obviously an iterative process. You can't write 10 tests and then try and implement those 10 aspects to your target method. That just wouldn't work. Too much would be going wrong. You do it in an iterative way. You carry out refactoring. Refactoring is really important because once you've got some part of an implementation working and you've proven that it is working because your tests are passing, then it kind of gives you confidence that I know it's working, and it gives you the confidence to maybe improve the design of your target method. And you can satisfy yourself that the improvement that you made hasn't broken anything because you simply rerun your tests, i.e. you do regression testing. So there are the key points of this TDD process. And I think that's all I cover in this set of slides, yeah. So that's kind of unit testing covered. We will come back to testing, but a number of the principles that I've been talking about, like test case isolation, testing state as well as responses, and all of the other stuff, those concepts and ideas apply to end-to-end testing and API testing as well. So the lab, if I flip over to Moodle, if we look at the lab section, okay, so you are in a position now to tackle this lab, and you will be required to submit as a zip the end product of your work on the lab, and you can submit it to this link here. I think by next Thursday, I think, is the hand update.